Caitlin, let's play the I'm guessing an integer between 1 and a 100 game. Okay?
Okay.
Think of a secret number and ask me to guess that number, Caitlin.
Okay.
I will use the binary search algorithm. Now you have to tell me whether I'm too high or too low.
Right.
And we'll record my guesses right here on this worksheet.
Okay.
After I've guessed your number, tell me that I played the game well, and tell me whether or not I guessed it within 7 guesses. I bet I can do it within 7 guesses. Let's begin. Okay, are you thinking of a secret number? Okay.
110.
Between 1 and 100. Okay. My first guess, Caitlin, is 50. Too high or too low?
Too low.
What's halfway between 51 and 100? 75 is my next guess. Too high or too low?
Too low.
What's halfway between 75 and 100? Oh, 76. 76 and 100. Roughly 87. 87 or 88. It doesn't really matter whether we truncate the 0.5 or we round up. 87.
Too high.
Too high? Whoa. So I know that the secret number is between 76 and 86. 76 and 86. Halfway between there is roughly 5 added to 76. 81.
Too low.
The must be halfway between 82 and 86. So let's add 2 to 81. 83.
Too high.
Too high? Whoa, I'm running out of guesses. I have 5 guesses and I only have time. I can only make 2 more. But you know what? I've just narrowed it down. It must be between 82 and 82. So let's make 82 that final guess. I did it. I only needed 6 guesses. I used the binary search algorithm, cutting the distance in half each time. So let's apply the binary search algorithms to some actual Java code. Let's see how it traces. We have an array, not an array list, but it's an array. Numbers is the name of it. Its length is, well, 0, 1, 2, 3, 4, 5, 6, 7, 8. Its length is 9, but these elements, these numbers, are in positions 0 through 8. Okay, I have some other variables that I just need: mid, low, high. Let's look at the variable high. High is length minus 1. In other words, high is 8 for this particular example. And let's pretend that we're looking for this key. The key is what you're looking for. We're looking for the number 65. Well, is 65 in this array? We see that it's not, but that's cheating. So let's trace the code to see if Java can figure out whether the 65 is there. A very important point. It's a precondition of this algorithm that the numbers that are in the array are already sorted in order, either low to high or high to low. They have to be sorted. This algorithm only works, Dan, if it's sorted first. Now that is a little expensive. Sometimes it takes space, random access memory, or it takes time, processing time, to sort a million things in order. Like Google's sorted every one of the billions of web pages in order, and so it's really fast. Well, kind of. But it's still good. It's still a good algorithm if you can sort things. Let's trace it. Okay, the variable found starts at false. I'm just going to use, I don't know, the letter F or something here for false. And low already we noted started at 0. And high is 8. And mid is currently 0. Okay. Okay, examining the while loop. Is low less than or equal to high? It sure is. 0 is less than 8. And is not found true? Well, found is false, and the not of that is true. So overall, not found is true. So when we have a true ANDed with a true, overall the while loop is true. So luckily we go through the while loop at least once. Mid's new value, low plus high, I can see is 8. 8 divided by 2 is 4. So mid is now 4. Now we analyze this if-else statement. If key is greater than numbers mid, Well, key is 65 for the duration of this whole exercise. Is 65 greater than, what the heck is numbers mid? Well, mid is currently 4, but because it's in the square brackets, that's telling you to go to position 4 of the array and look to see what you have in there. And I see I have the number 60 in there. So is 65 greater than 60? It sure is. So we do this statement, low equals mid plus 1. It's an assignment statement which works from right to left. So we do the math, mid plus 1. Mid plus 1 is currently 5. The 5 gets placed into the variable low. So low, unfortunately, gets crossed out here, and it's turned into a 5. Because we were in an if else, and the if was true, we skipped the rest of the else if else action. We hit this closing curly brace, which with good indentation matches us up with the while loop. So we have another go around. Because 60, well, I'll show you this later. Anyway, is low still less than high? It sure is. 5 is less than 8. And we still haven't found what we're looking for. So mid is reassigned. And mid is now whatever low plus high divided by 2 is. Well, low plus high is 13. And 13 divided by 2 is... Dylan, what's 13 divided by 2?
13 divided by 2, that would be 6.
Good. Why didn't you say 6.5?
Because it's not a double variable.
Because they are integers, correct. And integer division chopped off that 0.5. So mid's new value is 6. So I mark that here on my scratch paper. And we ask now, is key, which is still 65, is it greater than numbers mid? Well, numbers mid is now the number 91, because that's what's in numbers square brackets 6. So is key greater than, is 65 greater than 91? No. Is key less than 91? Yes. So this assignment statement executes the second time around. High is equal to mid minus 1. So high gets crossed out here, the 8, and mid minus 1, not mid, but mid minus 1, so that we don't re-inspect a number that we've already deduced is not the key. And so we go around the loop again, and we're honing in on the key if it's there. If it's not there, this algorithm ends and it tells us that it's not there. One more time around. The new mid will be low plus high divided by 2. 5 plus 5 is 10. 10 divided by 2 is 5. So mid is now 5. And we ask if key greater than numbers mid. Well, numbers mid is 74. And 65 is not greater than 74. 65 is less than 74. So again, we set high equal to mid minus 1. High gets crossed out, and mid, which was 5, minus 1 of that is 4. Interesting. We go around the loop again, and we analyze the loop's control expression. Is low less than or equal to high? No, it's not for the first time. 5 is not less than 4. So because you have a false ANDed with something else, the whole control expression at the top of the loop is false, and therefore we don't go through the loop anymore. Instead, we drop down here to this code down here at the bottom that asks if found. Found is a Boolean value, so you don't need double equals true. You can just type it this way. If found, well, found is false. So if false, that means we do not system out print that we found something in position. Instead, we scroll down a little bit here. Instead, we print out system out print the value key was not found. 65 was not found. And that's the binary search algorithm. There are different variations that you can use. For example, you could have used a for loop. You could have used a slightly different while loop. But a binary search is generally a loop with an if else inside of it, and it cuts the range in half each time it narrows in on the area where the key should be found if it's there. This all assumes that the input range, the numbers that you're sorting through, are sorted in order already.